Okay, we're continuing on day 1, part 2. When we look at setting up the generic Fanuc 5x mill post, one thing that's important to know is, what does the post support? If you scroll up to the top of the post, I recommend you do this with every post, but especially the 5x mill post. What did the post writers intend when they created this post? Typically, they will tell you up near the top. So I'm going to go turn off white space. Post name, Generic Fanuc 5x mill. Product, mill. Machine name, generic. Control name, Fanuc. 4-axis and axis substitution, yes. So this post will support 4-axis positioning and live 4-axis, as well as axis substitution. 5-axis, yes. Subprograms, no. So there's no support for nested subprograms in the 5-axis mill post. So be aware of that. Executable, version 19. Warning, this post is generic and intended for modification to the machine tool requirements and personal preference. Associated file list, and they just list generic Fanuc 5x mill .mcam-control. In the revision log, they talk about what was done to the post. Initial post update for Mastercam X back in 2005. Initial post update for Mastercam X2. Added previous shift drill equals 0. This is done in 07. X3 release, no changes were made. Post update for X4 in 09. Modified rotary clamping. Correct the can text order of stop and op stop. Initial post update for X5. Added fix for X style coolant output. Removed CD var variables. Added fix for 5-axis drill cycle reference output. Added arc type initialization to correct helix and full arc output when using R or signed R. Added tool table output option and header output. Added unclamp in P wrote red ink if foresee init and use clamp are enabled. Initial post update for X6. X coolant width separated coolant with logic from can text with logic to give more control over output of X coolant width. C PCAN1 and PCAN1 cool. So it gives us a clue there about coolant output. Then we have the post update for X7, 8, 9, and 2017 X10. It's not, it's 2017. But you can see that really, since X6, there really haven't been any major changes to this post processor. What tells Mastercam that this is a 2017 post? Anybody got an idea? Okay, so again, this header line, changing this header line version number will allow this post to run with different versions of Mastercam. Now, in our case, we're going to go back to 2017. And let's set up our first machine definition. When we look at the generic Fanuc 5x mill post, there are 4 different machine definitions that are available to us in Mastercam 2017 by default. So again, these versions in 2018 aren't there. You have to download them. Yes, 2017 equals V19 in the post. So version 19, 2017 here in this version line. By the way, POE1 have to do with the product levels in Mastercam. This T value is just a timestamp, so you don't really have to worry about the timestamp number. And the I and the O are for enabling special functions. One is probing, the other would be like pick off, cut off for lathe. So by default, they give us 2 different sets of inch and metric default machine definitions. So we have, notice, table horizontal and table head vertical. So why they don't also give us a head vertical, I'm not sure. But the reality is that everybody who's running Mastercam 2017 or lower, doesn't matter which one of these machine definitions you grab, because none of the configuration of the code output is done using the machine definition. That is slowly changing, starting with 2017. Now starting with 2018. I haven't downloaded any of the new posts for 2018 as of yet, because almost all of the stuff that I've been working with over the years has been built up using these posts where the switches are all contained inside the post processor and not contained in the machine definition. Oh, hey, sorry about that. Looks like I was still muted there for a second. Sorry, guys. We've got that in the video clip. Sorry, yeah, if you guys see me moving stuff around on the screen and I'm not talking, just give a little shout out, because sometimes I'll miss that. Sorry. Okay. So, with 2017, we've basically got these 4 different machine definitions. You notice we have table head vertical millimeter, table head vertical inch. There's no inch or anything after that, but that's what that means. We also have table horizontal millimeter and table horizontal for inch version. The reality is that it doesn't matter which one of these you use. If you're using the generic 5-axis Fanuc post from the X series, because all of the configuration is done inside the post itself. Now, if you're using the 2018 version, some of that stuff is changing, but again, I haven't seen those come out as of yet. I'm going to take mill, 5-axis, table head vertical, and select add. Then in the machine type here, I'm going to select that machine. Takes a second to load. And now we're going to edit that machine. So in the machine tab, we're going to go to machine definition. Tells us, you know, you've chosen to edit the disk copy of this machine. Changing this file will affect all future Mastercam files. Are you sure you want to do this? Yes. So it's going to open up, and now we're going to set this up for a gantry style machine. Anybody got a particular type of 5-axis gantry they want to set up? Think of as an example. Maybe we can do a Cincinnati. I was going to do a Jobs. Just as a particular machine. So Don says Cincy. Yeah, we'll do a Cincinnati. How difficult to do with the W-axis? Difficult, just because you have to be able to pass a variable to the post processor to be able to control that W-axis position, and you have to be real careful if you're going to be doing any motion breakup. As long as you can get away without triggering the motion breakup routines, you're probably okay. But all of the internal calculations for position are held in, you know, the binned portion of the post. So, yeah, that's definitely more an advanced topic. Let's stick with the basic configuration for now. So we're going to do a Cincinnati gantry. So, probably spelling it totally wrong too. Call this Achromatic 950. All right, and we're going to do a save as. So I'm going to name this Cincinnati 5-axis gantry Achromatic-950. I'm going to copy that name. So we've just saved the machine definition. On this particular machine, we actually have the configuration incorrect. So typically we would have the x-axis. Ooh, see if I can get it to drop on here. Yeah. Oop. Okay, so we want the X, we want the Y, X, Y, Z. We're going to delete them from the table group. Now, is it really necessary to do the configuration here? No. Because of the way that the post is set up. The post doesn't read any data from the machine definition, at least the post that we are working with. Some posts do. If you have a post from Postability, there's a good chance that Dave has configured it to read settings from the machine definition. But I like to do that just so that, you know, I know what I'm working with. What we're going to do is go on the Z-axis. We're going to add a component. We're going to add a rotary. And it's going to be a C. the world coordinate system axis of rotation is z. It rotates about the z-axis. Now, where is the 0 degree position? This is always a good question. On some machines, you won't know until you start rotating it around and see what happens. Part of the 0 position control for the c-axis is going to depend on what kind of secondary axis is attached to it. Is it an A or a B? So in our case, we're going to load an A, which rotates about the x-axis. So part of what we need to determine are some simple tests to be able to set up the machine and make sure that the output is correct. If there's one thing I can guarantee to you, it's this. If you can't make a simple example work, you're never going to make a complex example. So I sometimes I'll get these 5-axis test files from these guys, and they've got like 30 operations with a million lines of code, and it's like we don't need anything that complicated to test 5-axis output. We need some circles and some lines. That's it. I promise you. Now, is that going to be able to test everything? No. Sure. But we can do some fairly important and investigative tests with just some really simple geometry. For now, I'll set plus y to be the 0 degree position. Direction, clockwise or counterclockwise for rotation, doesn't matter because this data is not read by the post processor by default. Okay? Axis supports continuous positioning, blah, blah, blah. Doesn't matter. It's not read. Now, what I'm telling you is not true for a 4-axis machine. For a 4-axis machine and 4-axis generic post from Mastercam or MP Master, data is read for the rotary axis from the machine definition. But it is not for the X-style 5-axis generic post. Okay, so important thing to know. Same with the travel limits. Ignore it. Here I've got it set to Z, got it set to Y, whatever. That's the C. Okay, so let's rename this. It's gonna be VMC C axis, and just to drag and drop, I'll grab the VMC A axis, and we'll drop it on the C. We're going to add it as a child. So this is how our gantry is built. Husker's asking, are they looking to implement anytime soon? Yes, they are. I don't know what the state of their development is. I don't really know what's available on the site. Something you could certainly ask CNC Software. I mean, honestly, I don't look to it because I don't care, because I've been using the Generic Fanuc 5X mill post for so long that I don't need any functionality from the machine definition. It doesn't gain me anything. In terms of setting up a 5-axis post, I mean, honestly, once you know what you're doing, the basic configuration is like 10 minutes. Seriously. Now, there's a lot of stuff, don't get me wrong. There's a lot of stuff that isn't supported by default that you might want to add. G10 lines, G68.2 support. The default structure is there, but none of the logic is configured. So there is a ton of stuff that, would take you hours or days or weeks to configure, but a basic configuration inside the post is not one of those things. It's super easy. So let's get to that. A-axis rotates about X. We're going to call the 0 degree position negative Z. And again, it doesn't matter what I set there because it's not read by the post processor. We do need an axis combination. So table XYZ, CA tool spindle, and OK. And we'll save that. So now it's a valid machine definition. One of the things that happens when you start creating a new machine definition, a machine definition is really a Mastercam file, a Mastercam database with some other stuff attached to it. So you'll notice across the title bar of my Mastercam session, it says Mastercam Mill 2017, and then the file path, and you'll notice it says Cincinnati 5-axis Gantry Achromatic 950 MCAM-MMD. So it says that right across the top there because that's the file that we've actually got open. Once we exit here, I'm going to save those changes to the file. It's going to ask if we're going to want to replace the current machine definition we have loaded. I'll say yes. Okay, so I'm going to go back in the machine definition, and actually before I do this, I'm going to save this Mastercam file. And I'm going to do machine type design. You'll notice we're under machine type here, and then file new. What that does for me is that clears out the Mastercam database completely. So whenever I'm doing machine definition work, I always make sure that I start from an empty Mastercam file. And I didn't do that last time, so that was kind of my bad there. I'm going to go back in and do machine definition. I'll do open this time, because this thing is already here. Cincinnati 5-axis Gantry. We'll open it up. Now the reason it's important to start with an empty database, because here's what can happen. I've got this Mastercam machine definition open. You know, I go do something. Okay, great. I made a change. I save it. I exit the machine definition manager. Oh, looks like they fixed it for 2017. It used to be it would keep the machine definition open in the background. So in X9, there's a little bit of different behavior where it asks if you want to save the machine definition to a machine definition database or if you want to save the geometry to a Mastercam file. So it looks like they've actually cleaned that up a little bit, which is good. So machine definition. And the reason I bring that up at all is that if you're working on the machine definition with a Mastercam file open, it's possible to accidentally save part geometry from the part file you have open into your machine definition file. Because for each of these components, we can actually load a part of the machine definition. Unfortunately, there's some functionality that is available from ModuleWorks, but it's not really released to the public because they want resellers to charge people so that they can use it and ModuleWorks gets a cut. But basically, it allows you to hook up the machine definition to the machine simulation and kind of drive those together. It's actually the same system they use for the new MT product, which is actually coming along. I mean, they've got a long way to go, but it's starting to become a pretty full-fledged product and usable product. So, ooh, wrong one. 5x's gantry. Now what I'm going to do, you'll notice it's still pointing to the generic Fanuc 5x mil control. I'm going to copy the file name. We're going to go to edit the control definition. I'll do a save as. So as we set this up, right now it's linked to only the generic Fanuc 5x mil post. Now is the point where we need to go do a copy and rename to create our post file for us. So if I go to shared MCAM 2017 in the C users public documents, mil posts, here you can see generic Fanuc 5x mil post, generic Fanuc 5x mil PSB. And so what I'm going to do is I'm going to copy each one of these and paste it in the same folder. And then I'm going to rename it. Also going to copy the PSB and do the same thing. So now I've got a machine definition, a control definition, a PST file, and a PSB file that all have the exact same name. That's my preference, and it's the way that almost everybody out there builds their post processors, is to have a one-to-one relationship between the machine, the control, the post, and the bin. So in the post processors control definition post list edit section dialog box, I'm going to click add files. We're going to grab the Cincinnati 5-axis gantry, and I'm actually going to delete the generic Fanuc as a listing there. Now, in order for, so when we set up a new post, it's also important to make sure that that post processor is not open in a text editor. And the reason that's important is that when we select the post and save it, if we go down and look at the text, the text that's here right now is coming from the default text section that's in the post. Once we go in here and we make changes, so we go to drill cycle number 9. Call that subcall, and for the first PEC value, which is here, we'll say subprogram number. So I'm setting up drill cycle number 9 to call a subroutine. When I do this, when I put in these text strings and I save the control file, Mastercam writes these values to the bottom of my post processor. So I'll select OK. You'll notice this is Cincinnati Gantry Achromatic 950. Got one more thing to configure there, a couple more things, so let's do that real quick. Back in the control definition, file extension. What's the file extension for the Cincy? It's not EIA, is it? I know that's Mazak. Oh, Don, it's been a while since I ran the 950. Is it just NC? TXT? We can make it whatever we want, and we would set that here if we needed to set that. Yeah, it's for the 2100. This is for the this is for the 950 MP. There we go. That's what I thought. Okay. Yeah, no worries, man. No worries. You're right for the 2100. NC output. So sequence numbers. We'll start at 10. We'll increment by 2. Stop at 9998. We're going to turn on tool staging. No, this one doesn't have a tool stage, I don't think. Delta start to center is the default, which is IJK support. And we'll break at quadrants, that's fine. We're going to do helix in the XY plane. Jeremy says, what if it goes past 9998? It starts over. So it starts back over at 10, if that's what we set it to. Whatever the initial value was, it's going to start over at that initial value. So we'll leave all the rest of this arc stuff on. 5-axis, we're going to use inverse time for rotary. It's already set, so that's good there. Control support subprograms. No, it don't. So we're going to turn off subprogram support. Oh, this is interesting. Oh. So somehow there we selected a different control definition. We selected the router definition, which is not what I want. I want the mill. So it's important to make sure that you're set to the right option there. I'm glad I caught that. Okay, so we got the post. MP. Actually, no, we're just going to start at 2 as well. There's no subprogram support, so I don't need to worry about that. Now, when we go in and we make changes to a control definition that is set to a post up here in this file path, those settings are specific to that post in that folder. It's a static file path, which means if we want these settings to carry over the next time we upgrade to a different version of Mastercam, we have to set the default values. The easiest way to do that is to go in here and select default setting for control type. Go to any page in here, really. Right click and select import all pages. I'm going to import my settings from the exact same post that I was using. So I'll select open here. And we're going to grab them from this particular post in this particular location, and I'll select OK, and you'll notice those settings changed for me. So I'll save that, and that's going to save those settings to the default file, default settings for the control type, and then I'll go back to the actual post here. Save it and select OK. And now we're pretty much done with our configuration. I mean, if we wanted to set R output instead of IJK, I mean, we could go and we could do that in the control definition, but there's not a lot of other stuff that's read from the control definition. Most of it is set up in the post. So we'll select that and say OK. Say yes. Okay. Something that's fairly important to understand. If we go down at the top of the post header here, and we look at layout. So after the comments about what was done to the post, we have a section called features. And there's a section that describes basically each one of the miscellaneous real values and integers. So comments that describe what each one of those does. Then there are some more descriptions about features and functions of the post. Can text. So how to enter can text. Entering can text on a contour point from within Mastercam allows the following functions to enable disable. So they've got MO, MO1, block delete on, and block delete off set using can text options by default. Can text is a whole nother valuable function that exists inside the post because we can edit it to output NC code basically any place we want, either on a line of NC output or in front of or behind it. Then we get down to a section called layout. So the term reference view refers to the coordinate system associated with the top view. So when you do Alt F9, the upper gnomon of the three displayed axes. Polar positioning is offered in Mastercam 3-axis toolpath through the rotary axis options dialog. So this post will support polar output for 3-axis rotary. So if you want to substitute one of the, if you want to do distance and angle, you can do that for 3-axis polar. Axis substitution. Use the rotary axis substitution by drawing the geometry flattened from the cylinder. Okay. Tool change retracts. MI8 is used to control retracts at tool changes and null tool changes. MI8 for tool changes applies to the approach to the part to the retract from the part at the next tool change, unless changed in a null tool change. Okay, so if there is an operation change, it's going to control the approach to and the retract from the part. Null tool change control at a null tool change, that's a mouthful to say, uses the current setting and previous setting of MI8. So we're actually comparing the current to the previous. Through a null tool change, the setting of MI8 at the retract applies to the approach. Okay, so it's giving us some information about how to control the retract and approach at the tool change or the null tool change if the tool number repeats. Additional notes. G54 calls are generated where the work offset entry, work offs are set to 0 equals 54, 1 equals 55, etc. This post only uses work offsets, so there's no support for G92. Metric is applied from the NCI Met tool variable. Incremental mode calculates motion from home position at the tool changes. The home position is used to define the last position of the tool for all tool changes. Okay, so home position can be used to tell the post where to go, and if you're in incremental mode, what those distances are from the actual machine home position. The variable abs inc is predefined, should actually be abs inc $, and is set in MI2, miscellaneous integer 2, for the absolute incremental program output. Always avoid machining to the center of rotation with the rotary axis. Just a warning there. Set the precision to 7 place precision minimum in Mastercam. Set the tool vector length. Oh, that's cute. Vector. Set the tool vector length in the 5-axis toolpath as 1 unit minimum. Longer is better to avoid rounding problems. Output precision deviations. Okay, so it's a warning about how to actually set up Mastercam to make sure that your input to the post is in the best possible form. And what they're saying, use at least 7 place precision minimum in Mastercam and use longer tool vectors. So what they're talking about is in the Mastercam options here, configuration and tolerances. And what they're talking about is actually applying a system tolerance to make sure that your input in the form of tool vectors is nice and accurate. What they're warning against is setting a system tolerance that is not precise enough. So they're saying use at least 7 places. So 6 zeros and a 1. And what they're also saying is to use longer tool vectors, especially with a gantry. This is where it really kind of will get you. Even on a trunnion, when you are going around a corner that's got a lot of rotation and your tool axis vectors are really close together, you can get rounding issues. And that's basically what they're talking about there. Do what have an effect as well? Well, all of the tolerances in that screen will affect the amount of vectors you're going to create. I mean, there's all kinds of stuff in the tolerances for Mastercam that are important to the integrity of your code anyway. I mean, you go in and you look at configuration, you look at tolerances, chaining tolerance, minimum arc length, minimum curve step size, curve chordal deviation. So these are all defaults that are going to be used, and you know, the rougher your tolerances are, the more faceted your part is going to be. Okay, so yeah, these absolutely are used in all kinds of calculations. Now, personally, I think they're also talking about toolpath tolerance. You know, I would use at least 5 decimal places, if not 6, for the toolpath tolerance. So I like to leave my system tolerance a little bit finer than my toolpath tolerance, but I believe this is partly what they're talking about as well. Now, the tighter you make these, in general, so minimum arc length, for example, anything below that, this is just what is the minimum arc length of your machine. And anything below that, when you're talking about creating a toolpath, will get linearized. And it gets linearized using your chordal deviation number. The reason these numbers here are so high is because I was working on a gigantic part. And it just, with bringing it in, there were all kinds of toolpath errors. So normally, this stuff's a lot tighter. I don't like really, really small arcs. You know, some people will drop, you know, a 1/2-inch end mill inside a 502 bore and expect to be able to interpolate and do cutter comp with it. And I think that's just silly. I think that's a bad application that people are getting away with. You know, I understand sometimes you got to do what you got to do, but yeah, some of these will definitely get you there. Let's see where we're looking at here. Okay. The tool length. This is an important one. The tool length is taken from the overall length entered with the tool definition in Mastercam. This setting here is kind of a holdover from the days when we didn't have tool center point control. And what they needed was a way to be able to pass the actual pivot length of the tool from the center of rotation on the secondary axis to the tip of the tool into Mastercam somehow. So when we're setting this up for a gantry machine, it kind of changes the way that you have to do or have to handle tool creation unless you modify the post. So by default, when we create a path, and let's do something here. Okay, I'm going to create an arc and a surface here, and we're going to see what it takes to take a tool and spin it around 360 degrees on the surface. Now we have an A-axis that rotates about X, so the logical place to start, since this is the axis of rotation for the secondary, is either at the front of the cylinder or the back of the cylinder, basically the high point along the y-axis. And the reason for that is that we want to simply be able to tilt the A-axis 90 degrees, approach the cylinder, and then cut using the C-axis only. If we were to start the cut at the X positive, we would actually have to rotate C to be able to get to that position on the machine. So if we look, if we go home, and we hit display endpoints, you can see that the endpoint of this arc is at the X plus location. So what I'm going to do is do a transform rotate. And we're going to rotate those arcs. And now when we go and we look at the endpoints, they're in the Y minus location. Go ahead and save that. And what I'm going to do is create a line. And now we'll do a toolpath. Toolpath, multi-axis curve. Oh, actually, before I do this, surfaces, I'm going to do extend. Okay. Toolpaths, curve. Go select the library tool. Grab a 1/2 inch ball end mill. Cut pattern, we're going to do a 3D curve. I'm going to use the single option here to select that arc. That's the curve that we're going to drive. Compensation is off. We're just going to drive it centerline. Tool axis control is going to be normal to a surface. Grab the surface of the cylinder. Collision control, we're going to comp to the surface. And in this case, we'll leave 100,000 just because we can. We don't necessarily have to. Linking, we'll use the default. Everything else, pretty much, we're going to use the defaults. Oh, you know what? Keep the tool down within distance. And projection normal to surface. Maximum distance, we'll set 0.5. By default now, we just get tool axis motion that shows the tip of the toolpath trace. If we go in and we look at this in backplot, one of the options we can turn on is to view the tool axis vectors. And now we actually get to see the vector lines. So what happens in this operation? We drop in, we approach the surface, and now we cut around the surface, and we're cutting around. If we look from the top, we're cutting clockwise. So what controls that clockwise cutting motion? Why isn't it going counterclockwise? That has everything to do with our chain direction. So if I want it to go the other way, reverse the chain, regen, it'll give us basically the same toolpath, but we're going the other way. We're going counterclockwise instead of clockwise. So this is kind of, if we're using, it doesn't matter if we're using a Gantry or if we're using a Trunnion machine. The first test I always do is spin a circle. It's so easy. Create a cylinder, figure out how big the piece is, usually around the size of your platen, or whatever will clear from the center of rotation. So the WCS axes should always be put at the center of rotation on a trunnion part. For a gantry, it should just be where the 0 is located for the workpiece. Okay, so if this is our origin for the workpiece, maybe down on the table, I got it like 10 inches below, here's the path that we're going to trace. If I post it,